You can make a list of anything, including numbers, strings, images, and structs. You can even make lists of lists. To do so, we start with our list of numbers definition. We could be doing this with anything, of course, but we'll use list of numbers for the start. So a list of numbers is either empty or cons number list of numbers. Let's also make some examples of what that looks like. We can say that a count list is a cons1, cons2 empty, so this is a list of size 2. And then we'll make a 3 list, which will contain the number 3 three times. And finally, we'll make a short list that just has one number, but to make it interesting, we'll make it a big number. And now we need a definition of a list of numbers. So a list of numbers is either empty, as all non-empty lists are, and then a cons list of numbers paired with a list of numbers. Quite the mouthful. And we can create an example of what this looks like too. So we define a nested list as being the consing of a count list, consed with a 3 list, consed with a short list, empty. Let's think about what we created here. This is a list with only 3 elements inside of it. Each of those elements is, in turn, a list. The first one has 2 elements. The second list has 3 elements, and the third, last list has 1 element. But altogether, our nested list only contains 3 elements itself. Let's verify this with the interaction window. So we call nested list, and it produces our full representation, expanding out everything. Our first list element is our count list, which is cons1, 2, empty. Our second element is our 3 list, cons3, 3, 3. And then our last innermost element is cons 1000, empty. It can be hard to see these cons that are doing the gluing of our nested list, but they are there, and it's the same things we're seeing here. If we want to access elements of the list, we can use, as always, first. So calling the first of the nested list gives us the count list, cons1, 2, empty, which we have for our count list, cons1, 2, empty. We can also ask for the rest of the nested list, and this will give us all the elements after the first one, the cons3, 3, and the cons 1000. Now, to get the second element of the rest of the list, we just need the first of the rest. And that gives us the cons3, 3 list. We could ask for the first of that. So the first of the rest of the nested list, and put first in there one more time. That gives us just a single 3. In the same way, we could ask for the first of the nested list. So this would give us the 1 that was in the first count list. So, to wrap up, we'll write an example function that operates on a list. Let's assume we already have this function down here that sums up a list of numbers. So this is a function called sum. It consumes a list of numbers and produces a number, representing the sum of all the numbers in the list, adding them all together. The function consumes a list of numbers. If that list is empty, it produces 0. In the empty case, we have no numbers. If the list is a cons, then instead we add the first item in the list with the sum of the rest of the elements. Now we can write a function called sumLists that consumes a list of numbers. So sumLists consumes a list of numbers and produces a singular number. That number is, going to be the grand total list. So it consumes a list of numbers and adds all the numbers together to get the grand sum. Okay, so we need to write our header, define sumLists, a list of numbers, abbreviated LLN, ... We write a check expect. So we have our check expects up here for our sum functions. The sum of the count list was 3, sum of the 3 list was 9, and the sum of the short list was just 1,000. Now we have SUMLists, our function name, and we need a list of numbers. Conveniently, we've defined one up here, so we'll use that. This is our nested lists, and the result of that will be the sum of the count list plus the 3 list plus the short list, which is just 1,000, and 9 plus 3 is 12. Great, so we still have to define our function. We go ahead and take advantage of our template that we have for any kind of list handling function. We say cond, the list is either empty, elalon, in which case we do something. Otherwise, we have a cons, elalon, and we'll use something with the first of the elalon, and do something where we sum lists of the rest of elalon. And we just need to fill in our blanks now. If someone handed us an empty list of numbers, in other words, just a blank empty list, the grand total is 0. Then we just have to worry about the recursive case where we say that the first of a list of numbers is a list of numbers, and in order to find the sum of a list of numbers, we have our helpful sum function. So we'll say that we sum a list of numbers. We sum the first of a list of numbers, which is a list of numbers, resulting in just a number. And we know that SUMLists is an expression that when passed a list of numbers produces a number. So we can just add these two together. All right, and we can try it out. It was nested list, not nested lists in our example before. So we try running it again. All 6 tests pass. The template really helped fill in a lot of code, and when we followed it, even though we were dealing with a weird list of numbers, the template still helped us out. You know, we still had an empty and a cons case, and we just had to figure out what to do with the first and what to do with the rest, the sum of the rest of them. The trickiest part of this function is keeping the function names straight. We needed to call the sum function on the first element, which was a list of numbers, and we had to call the SUMLists, our recursive function, on the rest of a list of numbers, which was still a list of numbers. Lists of things does introduce new headaches, but as long as you're following the template, a lot of the problems can be smoothed out.